So that's great to see everybody. We are starting our second day of the synthetic intelligence workshop within the digital futures framework. Today we will jump into the GAN techniques that Artem will introduce you. So I hope you're ready with your computers, also ready to work. I hope that you all have just a Gmail account. It will be enough to work for today. You didn't need to install anything for this session, but for the session number 4, remember that you would need to install Rhino and Grasshopper. So since today is the class of Artem, we fully discuss and prepare it for you, but Artem, the stage is yours today. So I give you a host and you can start.
Okay. Hello, everyone. Nice to meet new faces that I didn't see yesterday. It's great that you joined. So today we will have GANs, generative adversarial networks, the networks that can generate images based on the provided data sets. And we will learn how to collect these data sets, how to prepare these data sets, how to train GANs. And I will briefly show how to generate images, we will generate images and point clouds from GANs tomorrow. Yeah. So I will share my screen.
Just to add few words, yesterday we were giving the introduction. What we in generally will be doing, and why do we collect these data sets, and what is the logic? No, so basically we are aiming to extract the intelligence of the biological matter and train the digital algorithms based on this intelligence. When you have a moment, if you missed the lecture yesterday, please check it in the YouTube. It's online. It won't take you much time. It's just like 45 minutes. But I think it's very important that you see the lecture for doing the next steps. So sorry, I'm silent.
So we can start. Yes. So first, I will do a brief introduction to GANs. What is generative adversarial networks and how it works. And then we will go to the practice. So since GANs appeared in 2014, people start talking about artificial intelligence as an artist, and it created a lot of discussions if neural networks can replace artists, or if it can help artists to create new way to create new images never seen before. Yeah, and during this period, GANs make significant progress. Like in 2014, it was just a small image of, if I'm not mistaken, 32 by 32 pixels, and it's not very realistic. But during the years, we get very realistic images. I prepared this presentation like a week ago, and during this week, NVIDIA announced a new GAN. I will show the video a little bit later. Yeah, but now it's even more realistic. So now we can generate images of 124 pixels by 124 pixels. It's like default sizes, but there are some hacks how we can produce larger images and non-square images, and I will show you this tomorrow. Yeah. I think the biggest case when people start talking about GANs as a tool for artists was in 2000 2018 when a group of artists named Obvious sold their image generated with GAN for $4,000. And also this case produced a lot of questions of what are GANs and what are art pieces now, because it's not clear who is the author. The guys who wrote the code for these GANs, or the guys who collect data set, or guys who trained the neural network. And like in this case, these obvious guys wasn't the guys who wrote the code and who collect the data set, and of course there was not the artists who paint the images that were in data set, but still the credit is theirs. Anyway, yeah, like it's almost 3 years passed already, and these questions are still open. But nowadays, GANs became more like a tool. You never produce the results, the output of GANs. It's not the final results. You use it to like intermediate step to produce something more. Like in our workshop, we will use GANs to produce the images that will later become point clouds, and after that we will do something out of these point clouds. And there is a lot of other cases. So what are the cases how GANs are used? First of all, it's an image generation. Like here is my project that I made with Yegor Kraft, and like here we produce like synthetic antique statues that are never never built before. Another option how we can use GANs is for image in painting, like to reconstruct corrupted images, or sometimes even draw new ones. Also, the wide use is for style transfer. Like there are one type of GANs is cycle GAN. It learns how to apply style of one image into another image or into the video. Also, it's used for upscaling. Like if we train GAN on a pair of the images, pixelated one and high-res one, we can then use it to generate high-res images. And now it's a lot of tools like built into like Photoshop and some other photo editors that allow you to upscale images. Also, very controversial way of using GANs is for deep fakes and living portraits. Like when we use GANs to replace one's face, or to animate one's face, it can be used both in very interesting and good ways, but also it's used to product some fake and sorry, Danny, I will mute you because you produce some noises, I guess. Yeah. So yeah, another option, like not, I'd say it's not how we usually use GANs, is to produce sound. We can make this, if I'm not mistaken, it's sonograms, or like visual representation of sounds, and we can train GANs on that and then convert it back into the sound. and it can be used to generate new sounds or mix different sounds, and never can be mixed in audio editor. So it's an interesting way to use GANs. And of course, GANs can be used for 3D generation. It's still, the progress is still ongoing, and for now there is no out of box, like ready to use GAN for 3D generation, but a lot of efforts made to make it possible. So so I think soon we will get something interesting. So yeah, now I will introduce some popular GANs, like most those GANs who which made kind of revolution in image generation. And first, I think I should explain the overall architecture of generative adversarial networks. Actually, it's two neural networks that work together. One is a generator and another called discriminator. And the main task of generator is to generate images, and it generates images from random noise. So it somehow converts these random numbers that it gets in the input into images. And task of discriminator is to recognize, we provide these generated images to discriminator, but we also provide the real images to discriminator, and the task of discriminator is to recognize if image is real or fake, and if it recognizes the real images as real, it updates its own weights, like it learns which images are real. But if it recognizes fake image as real, then it updates generator's weights, and generator understands that if he produces this kind of images, then they will look like the real one. And this is how these two neural networks train each other, and it train each other until they get more or less satisfiable results. Like the generated images will look like the real ones. Of course, there will be there is no way to generate exactly real ones. The generated images will be always will always have less quality, but anyway, the results are sometimes amazing. It's often this play between these two neural networks often compared to the like how police and those guys who make fake money work together. Like the criminals make money, and police can recognize it, and they arrest criminals. But next time, criminal produce more realistic money, and police will have some time to find out how to reveal which money is fake and which is real, and so on. Like I think it's most popular example, like illustration of how these two neural networks work together. There are a lot of GAN architectures, like this GitHub repository. Someone tried to collect all the GANs that was created till I think the end of 2000. 2018, by that time it was like hundreds of them. Now it's even more. Of course, there are some, like most of them are like made to work better with some certain data sets. So it's not like absolutely new, unique architecture, but it's just fine-tuned one. Yeah, and I think the most like the GAN that made this revolution in image generation was DCGun. It appeared, I think, in 2017, and it allowed to generate big images, like I think up to 512 pixels by 512 pixels, and this was exactly that GAN that was used to produce this portrait, famous portrait. Yeah, and DCGun had this classic GAN architecture, like two neural networks working together. But later it was updated, and in 2018, the progressive growing of GANs appeared. Here we have not just two pairs of generator and discriminator, we have more of them. Each pair is trained to generate images of different sizes. Like it takes initial data set, then convert it into 4 by 4 pixels, 8 by 8 pixels, and so on, up to 124 by 124. And it first trained to generate small pixels, then the next pair of generator and discriminator use the knowledge of previous one, and it generates the bigger picture, but it already knows the structure of the images, and it's just update the details. And this is why in the end we get these realistic images. It still has some artifacts, but it's much better, much more realistic than DCGun. The update of this architecture was StyleGun, and the first version, it still had this progressive growing of GANs as a core, but later in StyleGun 2, they got rid of this progressive growing, and they just keep the style style units, like instead of StyleGun is learning the style of the images, like colors, the shapes, and so on. And this is why it generates even more realistic. It can generate these good details, like the hair and so on. It's much more realistic in StyleGun. And we will work with the newest version of StyleGun, StyleGun 2 ADA. ADA, it means like augmented data set something. It's just allow us to work with smaller data set than original ones. And if we talking about data, the more data we have, the better results we will get, because the network should learn a lot of details to make the image to make high quality images, and also it's good to have uniform data set. Like in case of faces, we have all the faces aligned, so the eyes, nose, and mouth are always on the same parts of the image. So when GAN learns it makes GAN to learn faster. Like it always knows that here will be the same type of information, and it will spend less time learning this, and spend more time on learning other details. Yeah. In the new style GAN, in the new GAN, I forgot the name. NVIDIA proposed a new approach to image generation. They learn the structure of the image. So if it's a face, it learns the structure of the face, and even if it's not aligned to the center of the image, it still can generate proper results. Yeah. Also, the learning, the training of style GAN, it's quite time-consuming process. Like if we want to train it from scratch, it will take something like 2 weeks. Of course, we don't have this time during our workshop, so we can use the technique called transfer learning. Here we can, this technique is like we take already like pre-trained neural network that already can generate something like, for example, faces, and we provide to the network this model, the knowledge, and we provide new data set, and neural network tries to generate new images with the old model and update this old model to make proper results. And because the low-level features of the images, like small patterns, small like diagonal lines, vertical lines, some dots, and so on, are almost the same for any image. And the difference in high level, how all these patterns combine together. So so we skip the huge part of training when we learn these low-level features of the images, and just learn the high level, how these faces are different from, I don't know, maps or from microscopic imagery like we will use today. And this reduces the training time from 2 weeks to 10 or 10 hours, or maybe 20 hours. It depends on data set and the quality you want to get. I will share this presentation. There is also links to some pre-trained images, pre-trained networks that you can use. And now we will go to the practical part of the workshop, and for this I have to share some links. Before we go to this practical part, maybe you have some questions. No questions.
I have one. Hi. Can you explain again the difference between like the GAN style database you were using with the transfer one? Like, what kind of information is make the process much more quick in the means of how much time it takes to analyze the data? Does it need to use less images, or it makes like a macroscope idea of an image, like you say, with some lines or points or dots?
Yeah, I will show you this website, Microscope Open AI. Yeah, it's the great website where you can learn how different neural networks structured. The reason why I showing this, it's to explain a little bit deeper how neural networks, like the architecture of neural networks, have it consists of neurons which form the layers of neurons, and each layer of neurons learn some features of the images. Like here we have, it's better to show another one. I think this one would be great. So yeah, we have multiple layers, and like here we in the very beginning we get the image, and if we look at this layer, the first layer, we can see that the neural network learn the like low level features, these patterns. So first it gets this like horizontal lines, vertical one, and some diagonal one. And if we go to some other layers, like somewhere in the middle, we will get more complex one. Here we already can see something like eyes, or I don't know, even heads or dog heads. So this is how it like learn high level image features, and in the end it gets very complex one. And when we train GANs, it also learn how to generate such kind of features, and such how to combine these features to get the final result. And as our images, like the structure of the image is more or less the same. Like we in any images we will get these patterns, but on the high level, how these patterns combined with each other, it's different for different types of images. So we skip these first steps and learn only how to combine these low-level features to get the proper images. Is it clear now?
Yes, thanks.
Yeah, great. So yeah, I will stop sharing for a minute because I need to. Yeah, so we will work with GANs in a cloud platform called Google Collaboratory, and I will share the links that will be that we will use. Here is the link for Collaboratory. You should open this link, and then this link is where we have notebooks, the documents that can be opened in Google Collaboratory. And the last link I will share is this one. It's data sets that I collected for you, but well, I'll explain it a little bit later. So I will share the screen again and show what we should do with all these links. So first I open the first link. And I will get this screen like where and here to start working with our notebooks, with our data, I should go to this GitHub tab and then open the second link, GitHub, copy this link, and then paste it here, and then click search. And it will find three documents. We will start with the first one, data preparation, because first we need to prepare data that we will later use to train style gun. So I just click the first link, and it will open this notebook. What is a notebook? It's just a collection of cells. Yeah, and each cell can be text cell or code cell. I I hide all the code from you because we have different levels. Someone know how to code in Python. Someone never coded before. So I made very like user-friendly notebook where you don't need to code anything, just to provide the path to the data set, to the directories where to save the results and so on. So just adjust the parameters and get the results. But anyway, like I can demonstrate that we have it. Like if I double click on the cell, I will get the code on the right side, and I can hide it by clicking on the right side again. Yeah. Also, what is really useful to know about Google Colab is that we have this sidebar on the left. Here we have a table of content to quickly navigate over the notebook. Also, we this tab, this icon files is very useful. Like each Colab notebook is like virtual machine on the Google server, and it has its own file system there. And we can upload files, and we can connect our Google Drives and work as this as a drive, yeah, to store files there or read files from there, and we will be using it. Yeah. Also, here we have a menu, and sometimes we will need to do something with runtime menu. Like if our notebook stuck for some reason, like we ask it to make some impossible tasks, and it is working and produce nothing, we can restart it by using this restart runtime. Or if it's stuck really bad, we can use this factory reset runtime. It will recreate this notebook from scratch. Also, if we have multiple notebooks running, we can manage session, like to stop notebooks that we do not need anymore. And the reason why we should do that is Google Collaborator is free, but it has certain limitations. Like if they provide GPU just for 12 hours a day, and you can run only one notebook on GPU. So if you want to if you run one notebook and then you want to run another one, you should stop the first one from this menu. Yeah. Also, when you run your notebook, you should check it from time to time. Like when you start training, you should check it from time to time, because if you don't do this, Google Collaborator will think that you don't do anything with it and will stop the session. So it's like another, I don't know, not a restriction, limitation, yes, that we have to check our computers from time to time, not just start training and go away. Yeah, so anyway, I hope it's more or less clear, but we will work with this notebooks today and tomorrow, and I guess if you get any questions, you will find out how to work with it. So I will start. No, before I start working with the notebook, I also use the last link. Like I said, to train the style gun, we should provide some images, and you can collect images by yourself. But I already prepared some data set. Here we have some bacteria, like small cells. Yeah, that kind of images. Also, some carbon microscopic imagery that can be also used for generation. Some wood structures. This is very small data set, but I hope we still can use it. Oh, sorry. Yeah, this kind of images, just cells. But I think it can provide interesting structures when we go from 2D to 3D. And the last one is also cells. There is 3 folders. I guess this one is temporary. Yeah, I think I should delete it before sharing. Yeah, this look like this. Just microscopic images of cells. Yeah, well, to work with these data sets, you should open the link and then click on this triangle. And then, sorry, I have a Russian version here, but you will have add I will change the account. There should be English version. This. Yeah. Yeah. If I click here, I will have this add a shortcut to Drive, and then I click on this arrow, and I can add shortcut to the Drive directly, or I can create new folder and add shortcut there. I think the best option is to create new folder like digital features workshop, and click here, and now I can add shortcuts, and then I will use these folders to store the results and so on. I close this and this. So if I open my drive, I will have this folder, digital features workshop, and I have these data sets here. So now I can work with it. This, yeah, now I can work with it, and I will go to this collab, and I will run the first cells in this cell. Yeah, I'll got this message, and I should click run anyway. It just warns you that you are running the notebook that was created by some other person. Also, it's good if you save before running the cells. It's better to save a copy in a drive, so it will be stored on your drive, and you will not have. Yeah, I will show how it works. So it creates a copy. It will open new tab, but also it creates a copy on your drive. You will have this folder called collab notebooks. If I sort it by date, yeah, I have this copy of dataset preparation. It's exactly the same like this. So later, if you decide to work with some other data sets, you just go to your drive to collab notebooks and open this file, and you will you don't need to go to this GitHub and copy and paste all the links and so on. So yeah, I will continue to work here because I already have several copies of these notebooks. So yeah, after I imported libraries, I need to define some functions, how to work with images, how to resize it, how to crop it, and so on. If you're if you're good at Python and you want to somehow modify this code, you can double click and look here. We have like a function to crop image, to save this crop, and so on. So it's I think I will not stop here because we all have different backgrounds, and it will take a lot of time to explain how Python works. But anyway, if you know how to work with images, how to work with Python, you can modify this code. Yeah, so after I imported these functions, I will go further and I will mount my Google Drive. So I can work with data stored on the Google Drive. When I click this play button, I got this link and this like field where input field. I should click on the link and select my Google account, like where I have these data sets. Click on all the buttons like allow, login, allow, and so on. And in the end, I will get this code. To copy that, I can click this button and then go back to notebook and paste this code here and press enter. yeah, it will think a little bit, and then it says that the drive is mounted. If I update this file list, yeah, I get this drive folder, and if I see what's inside, I have this my drive, and then I have all the files I have on the drive, and this folder that I created right now, the digital futures one, and yeah, also the data sets. Yeah, like I can look at data sets from here. If I double click the file, I'll get the image here on the right side, and I can close it. Yeah. It's very useful to work with this file menu because we will have um, we will have to define the path to the directories where we store the images, or where we can we want to save the images. So just remind you that you can get this list if you click on this folder icon on the left. Yeah. Well, how we can modify these data sets? I have several functions here. The first one will crop the center of the images, like yeah, I think I didn't mention, but style GAN and all the GANs they can be trained only on square images that that has sizes like 124 by 124 or um, 512 or 220, 256, and so on. Yes, so the biggest size is 124. So to prepare data set, this training data set, we have to resize these images, and sometimes if we have a small data set, we should augment it. Like the best way, we can start training when we have, I think the minimum from my practice is 100 images. The optimal size of that data set is 2,000, 5,000 images. So yeah, I think our data sets are not very big. I'll check. Here we have 50 images. So yeah, yeah, the computer works very slowly when the Zoom is running. Yeah, or like here we have 20 something, yeah, 24 images. So we definitely need to augment this data, and we can do it by rotating the images. So here we have several parameters that we have to set up. The first one is input directory, the directory where is the images stored. I think I will work with this carbon data set. No, I think I will work with wood data set because it's small, and I will have to show you how to augment the data. But you're free to choose any of that. So I need to provide the path to the directory where it's stored, and I can do it by clicking these three dots near the directory, and then copy path. and paste it here. No, sorry, I didn't copy. Yeah. So now I have this path. It's better to end it with the slash, but I think yeah, if there is no slash in the end, it still be working. Yeah. And yeah, and then you should provide the path where you want to store the output. I will create the folder here. I can do it again by clicking three dots and then new folder, and I'll call it data set, and then copy it and paste it here. And then I will call it. Yeah, for the demonstration purposes, I will create small images. Just it will be working faster and it will be trained faster. But you should make this big one, 124. Well, I think I can do it. I can do the big one because I have some other images already prepared. Yeah. Also, sometimes you have, yeah. What this cell will do, it will resize the image in that way that the smallest smallest side of the image will be 124 pixels, and then it will crop the center of the image, crop the square from the center of the image. But sometimes we have some watermarks in the lower part of the image, so we can define the ratio and the crop, not the whole image, but some smaller part. So if we have one here, we will crop the whole image. But if we reduce the size, we will crop the smaller part of the image. You can play with it later. Also, we have this checkbox augment. If I will show how it works with and without this checkbox. So I will run this cell and we'll see the progress. Yeah, now it's finished. It cropped just 24 images. If I go to this folder, datasets, I just have these square images, and it's still 24 images. But if I click on this checkbox, I will get much more images because it will rotate every image. Yeah. Also, I'll show how this crop size ratio works. But I will save it to another folder. Yeah, I will run it again, but while it's running, I will show the results. Yeah, so yeah, so in this wood folder, now we have 50 items, so 2 times more. So it's just rotate. Like the same image, but it's rotated 4 times or 2 times. Yeah, this is how we can enlarge our data sets. Also, yeah, this is finished, and I will show how it crops its ratio. I guess I need to open another tab to compare. This was the original one, and here we have just the center of it. Just this part, and you can adjust this also sometimes when you have non-square images, you can make bigger data set by slicing it. Like this cell will analyze the image, and if it's not square, it will cut it into several squares. I think for this purpose, I will use this nuclei, yeah, this folder, nuclei, color Wikipedia. Then paste it here, and I'll copy this path. And name it. So if I run this cell, yeah, I will show you how these images look like. It's not, I guess it's better. So here. So yeah, we could see that it's not square. Not of all are square images, but after running this cell, we will get all the images will be square. This also allow us to get bigger data set than it was in the beginning. And we also have this option. Yeah, we also have this augment option, so it will not only crop these squares but also rotate them. But I guess we don't need it for now. We have 96 images initially, and after cropping we will get even more, and it will be enough to train the network. Yeah, also, yeah, while it's cropping, I will explain the next cells. Also, sometimes when you prepare a data set by yourself, or you download it from somewhere, and you look through that and see that all of the images are squared and so on. But sometimes it happens that there are some PNGs with transparent layers and so on, and we should get rid of this transparency. and be sure that all the images are not just squared, but have exact size of 124 or 5, oh, sorry, 1024, 512, and so on. We can run this cell. So it will not crop anything, it just resize and remove this transparency layer. I will not run it right now because I don't have any transparent examples, but sometimes it's useful to run this cell. Also, the last cell is like how we can auto enhance images, like we already crop it or resize it, and we want to adjust levels or gamma, or maybe invert the images. So here we should provide path like I will adjust images that we just cropped and put it to the second folder. Like for example, I will make auto level. Yeah, I think auto level is enough to demonstrate. Yeah. After we cropped images here, we got 278 images instead of 96. It's already good to train the style gun. So while it's enhancing, I think we can already check it. Sorry. So yeah, here we have our cropped images, and I will sort it by name just to compare exact files. Here we have something like this, and the third one is like this. And then if we go to the top one, to the not top, but adjusted one, we can see it has some different colors, like it adjusted the levels and so on. So sometimes when you have not very contrast images, you can run this cell and get better results. Yeah, I think we are done with this notebook. Does anyone follow me and try to do the same steps? No one?
Anybody here, guys?
Yeah, I just looking for you, and I'll repeat it a little bit later.
Okay. Also, I'll give some advices how you can find data sets like already collected images. Of course, you can just Google for it and download it from Google, but also there is some places where you can find it. It's that. No, let's search. Yeah, this site. I'll share it in the chat. You just type here like let's say, and it will provide some links to the data sets or to the articles that are connected to these topics. And also another site where you can find the data set is Kaggle. It's a website for data science competitions, and people share their data sets and codes and code how to work with this data set. So you can go to the second link, this kaggle.com/datasets, and search for data sets. All these data sets that we use today are from here, like this wood microscopic stuff. It's from here, and all other data sets are from here. So this is the way how you can find the data sets that already collected, but I think it's better to reference the source of data sets when you will publish the results. Or either, yeah, like I said, you can just Google for it, like mycelium, and then go to the Google Images, and there are a bunch of programs that are called scrapers, and you can Google for it, like Google image scraper. There are some like code. I think it's you should reveal how to install it, and I think I will not explain how to work with this, because it's always raise the question of legal rights for the images, if you can download it like this and so on. It's just up to you. If you want to do that, you can do that, but we will keep it out of this class.
Yeah, but it also depends how you want to take the workshop. If you want to discover something individual, now maybe you already have been working in some material studies and you want to work with your previous data set, that's great. If you want to look for the new data set in the internet, that's perfect. Or maybe you just want to take it more as a kind of exercise and take the data sets that we have prepared for you. They are open source and legal, so we can use them. And we can just share them with you, and you can choose one of three. No, we have three, and work with one of them. So you just kind of follow up and you do some steps. And further on, of course, you'll have all the notebooks available for you for your next project, and you can be implementing it more specifically. So it's up to you. For us, of course, as more variety do we have in the work, it's more interesting for us. And if you look for your individual data sets, which will start to drive the proposal, of course, it's more interesting. Think that, for example, yesterday I was explaining you the project of my PhD when we are taking the wooden pattern, and there is like quite a strong work in the preparing data sets, collecting it, understanding what we are using, how do we relate different section cuts, and then this starts to inform the next steps of the design iterations. So here actually the preparation of the data sets is very important. So do you want to take it in the same way and think which is the material that excites you the most? Now, do you look into the patterns of the physarum as I was showing last time and looking to the intelligence of this biological creature, or you are looking to the myceliums or to the patterns, I don't know, of your skins? Maybe some of you might have a small microscopes, which are just like, the small hole microscopes. Feel free to make your own collection of the images. Just remember that you would need at least 100 to keep training. So yeah, that's up to you, but you can, again, you can take an easy step and just take what we are sharing with you.
Yeah, before we go to the next part, maybe you have some questions.
I wanted to ask something.
Yeah.
In some of the, I've been following along with the GAN thing, and some of the pictures that we've processed have text on them, and some of them have like, I think it's from a scan that has like 500 microns, but some of them have random text on them. Can we edit that out, or is this just part of the image?
I think you can either delete these images or somehow blur this text in Photoshop, for example. Yeah, you always can work with all these images in Photoshop, not just in Google Colab. Yeah. It's better not to have text on the images in the final data set. So, because if we will have text, it will be, StyleGun will also try to generate text, and it will affect the structure of the image. I guess it's not like a disaster if we will have text there, but it's better not to.
Thank you.
Any other questions? Well, also I have another question. If we should make a small break, like 5 minutes or 10 minutes break before we go to the next part, or yeah, good. So I think we will have a break for 5 minutes, and then we will start training the style game.
Super. Meanwhile, I'm also sending the links to the all the links that we have here in the chat to the WhatsApp group that you have them saved.
Yeah.
Super. See you in a bit.
Well, I think we can continue. I will wait for a couple of more minutes before you come back. And we will start the second part, the most interesting one. Is everyone here? Oh, yeah, people coming back.
Yes.
Good. Then I will start. I'll share my screen again. Yeah, we should open another notebook for this. I will open again the collab, and yeah, I also need to paste this GitHub account, GitHub repository, and now I will work with the second notebook called SG2 Ada PyTorch. This means StyleGun 2. Yeah. So this notebook purpose is to train StyleGun. And there are some steps that are already familiar, like we will mount the Google Drive and we will install StyleGun on your Google Drive. So so you will not have to install it again later, or all the training results will be stored on the Google Drive, not in the collab files. So yeah, first of all, I will stop this notebook. I will close this notebook where we were working with data. And yeah, as it is another notebook, I have to mount a Google Drive again. Yeah, I'm just running notebook, but for you, it's better to save the copy on your drive and then work with the notebook. So you will always have your own copy, and you will not have to open it again from GitHub. So yeah, just click the link and copy this code. Yeah, after the drive is mounted, can show we will install the StyleGun, but before we start it, I will show what exactly we will have. We will have the folder called StyleGun, collab SG2 Ada, and so on. Yeah, and I think it's better to show it here. It's just all the StyleGun code that we will use, but we will not work with the code directly. We just send the instruction, and we will run the scripts that are already coded. And also here we have the folder called the results. So sometimes we will have to go to this folder. Like I already trained some StyleGun models on my own data sets. And we can look at the structure of this folder. So when we will train data set, it will generate this folder and put the intermediate results and the saved model, this pkl files called model. It's exactly the data, like the knowledge of this StyleGun. So if we want to generate images with this, we should load this PKL file, and then we can generate. I will tell a little bit more about structure later when we start training. But anyway, you know now where to find these folders. Yeah, so I will install this. This cell is structured in that way that if you don't have this folder, this collab is G2, it will create it and download the DCGun and all the needed libraries and so on. But if you already installed it, it will skip this part and just load the libraries to work with the DCGun. So you have to run this cell every time you want to train DCGun, but it will download DCGun only once. So yeah, after it was installed, we can prepare data sets. Like the previous step was when we prepared the right format of the images, and here we will convert those images into the format that the neural network can work with. Before this version of DCGun, the freshest one, it was some strange file format called TF records. It's just big binary files where they put all the images inside one file, and it was like one image after another, but you cannot view it or somehow work with it just to pass to the DCGun. But in the last version, they changed this process a little bit, and now you can work with just zip files. So you can either provide the path to the directory where you have all the images, or you can compress the images that you have on your local computer, upload it to the Google Drive, and you can skip this step. But I propose to use, as we have all the data sets on the Google Drive already, we will run this. So I will go to that newly created directory where I saved data sets. And I will use this folder. Okay. Yeah. I just resized those images one more time. I made it just for demonstration purposes. Yeah, I made it 256 pixel wide, and yeah, so it will be training much faster. But for you, I recommend to work with 1024 pixels images. So yeah, I will copy path to this directory and paste it here. And also I need to define the path to the zip file. So I will call it, you can call it just dataset.zip, but it's better to call it somehow more informative, so you will identify those files later and understand what kind of data you have there. So this is the path where I will store this data. Yeah, it runs pretty fast. It also checks the images, like if you have images of different sizes, like different resolution in the same folder, this tool will will inform you like you have different resolution, and it will not work until you prepare the proper images. So it's just the last check before we train the network. Yeah, so it's almost done. Yeah, it's done. Now I have to copy this path and paste to the next cell. So the network will know which data set to use. And also, like I said, to speed up the training process, we use the style transfer, not style transfer, the transfer learning, and we will use default pre-trained models that are trained on face data sets. Yeah, and as I have images that are that has size of 256, I need to paste it here like this. But if you have a size of 1024, then you just keep this value. Also, later, like if you trained for some time, yeah, if you start training and you trained for some time and then collab, you reach the collab limits, like 12 hours, so sometimes it's even less because it counts like machine hours, so it start counting from the moment you start the notebook, not from the moment you start training. Yeah, so if you reach the limits and it stops the training, you can continue training by providing the path here. Like I will show it right now. And I also repeat it tomorrow when you will have your own models. But anyway, I will show you now. Like yeah, like I said, in this results folder, I think you don't have it right now because you didn't train anything, but I have it and I show it. So yeah, I go to this result folder and then I choose one of the results, and in this result folder I have files network snapshot something.pkl, and I just copy the path for this file and paste it here. So it will start, it will retrain this model and it will not start with the faces, but will start with something you trained before. I will delete it for now. I think I will repeat it tomorrow when we all have our own models and we can continue training it. Oh, sorry. Yeah, you should put 1024, but I will train the lower resolution. So when I start this cell, it will download this pre-trained model of StyleGun. And then it will load that data set and will start training process. It looks like this, a lot of technical information, what kind of images it's loading and so on. Okay. Problems here. So it says that I have different sizes of image and the pre-trained model, and it's strange because I asked him to load, like it says that It has the size of 512, but I asked him to load different model. And I need to reveal the problem. It can be no. Well, I think the fastest ways for me is to run a bigger one. I guess the problem can be with the images, not with the model I downloaded. Maybe I resized to the, no, the size of the images is exact the same. So the problem was with models. Well, sometimes it happens. Sometimes we get errors during the training. It's great that we got it during the class, so we can find out how to manage with it together. I guess they have some problems with, yeah, interesting. Sorry, I just want to wait what kind of error it will show this time. If it will show an error. That's fun. I need to check my images, I guess. Yeah, I will review the details. Google don't show the information. Yeah, then I will download and check it. Yeah. Some mysterious things happening because the image has a dimension of 256, but when we load the model, it doesn't work with corresponding model, but works with the bigger one. I guess maybe in the code the developers of StyleGun missed the proper yeah, provided the not proper links to the models, so it downloads. It says that it downloads the big one, but downloads small one. But everything should be fine with this the biggest one, the biggest resolution, because I already tested before, and I never tested the smaller resolution, and this is why we met this during the workshop. I never checked this before. So anyway, it's now it's training, and we know that it's training because we get this line of text started with tick 0. So tick, it's kind of some kind of iteration. It goes through all the data set and learn the image features, and when it learn all the images for one time, it will learn it again in another iteration and do it iteratively. So right now it's still the first iteration is ongoing. And I never tried to train on these small images on collab, so I don't know exactly how much time it takes. But for the biggest images, for the 1024 pixels, it takes around 40 minutes for one iteration, and the best results appeared after, I think, 10 iterations and further. But you have to look at the results folder and monitor the progress, because at some point it will be overtrained, and it's not like the images start degrading. It will produce some results that we don't want to. I will show you. Yeah, we will go back to these result folders, and I will tell more about its structure and files that we have there. Like, yeah, the latest folder is the folder with the current training, and it has several files like fakes in it. It's initial like it's images that like we have initially. If we start from scratch, we will have just noise here, just no information. But we started with the faces model, and yeah, we can see here some faces. Reals is the real images from our data set. Network snapshot .pkl is the model of style gun that I'm trained currently. Yeah, and the most recent model will have some other digits and zero. Like currently it's 0 because we have tick 0, but later we will get your model, and all of them will be stored here. And yeah, usually they have a file size of 340 or 350 megabytes. So you have to clean your Google Drive from time to time and deleting these files that are not needed, and you can recognize which file are needed and which is not by looking at these fakes .jpg images. They have the same number here, so this image is corresponding to this one, to this file, and so on. Yeah, and this image is the current result, training result. Yeah, so we can learn where we now. Yeah, right now we have just one image. If I go to one of my previous training, I have more of these images and more of these network snapshots, and I can check. Like in the beginning, I had just faces, and then it starts modifying into something like the faces are degrading. Yeah, and becoming ugly. Yeah, and then I stopped training for some reason, I don't know, but in the end it should be this iRetina. I also can find some other examples of how it works. Yes. Yeah, maybe I already deleted them. So I usually work on my local computer, not on the lab. Yeah, like same with the maps, the satellite maps. So, yeah, I want to find the one where we go from faces to the proper imaging. Yeah, yeah, I'm sorry. It looks like I cleaned all the unnecessary directories, but anyway, I hope you understand the principle that we just monitor this folder until we get the results that we think we are good. I'll go back to our current results. It's still training, and I think it will take like maybe for these small images, it will take maybe 20 minutes. For the big images, it takes 40 minutes. And while it's training, I will try to open another notebook in another browser, just not to stop this training. Yeah, so while it's training, I will show how we can generate images. I will just briefly show it because we will have some time tomorrow. So, well, before yeah, I have multiple Google accounts because it's one of the way you can train multiple stuff in Google Colab and avoid all the limitations. Oh, why? Okay. Now everyone knows my age. Anyway, yeah, I'm in the laboratory now. And I will load the last one. the last notebook. I think for now you don't need to repeat after me because you still have your models training. Actually, I will check mine. Yeah, we already I already get the next peak, and it took 12 minutes to get there. So every 12 minutes we will get new results, and new model will be saved. Like, yeah, let's check what we have now. Yeah, it's still faces, but if we zoom in, we can see that they are already corrupted, or yeah, look a bit different from the previous one. I guess in two like one more or maybe two more ticks, and we will start getting, like, we will get rid of the faces, and we will have just our images, maybe not in the best quality, but no faces. Yeah, before I switch to the generation process, maybe someone has questions. Okay, anyone follow me? Maybe someone has. Yeah.
Hello.
Yes. No.
I have a question. I have a question about snapshots, snap
Yeah.
count. How often should we save the PKL file?
Uh-huh.
Or
So
we need to save each count, or what?
it's better to save each count when we train on Collab, because Collab is pretty, like, because of its limitation, it has, like, can stop at any moment, like after 12 hours of training, or sometimes it's also like if you don't check this tab, it can disconnect from Google, and it will be also stopped. So during the training, you have to check this tab from time to time. Yeah, so it's better to save it every tick, and this is why yeah, this training script has option to save it more rarely. Yeah, not every tick, but every 10 tick or 100 ticks. Yeah, if I just double click it, this is the command that start training, and we have the option here that's called snap, and I set it to 1. That means it will save the model every one iteration. But if you want to save it less regularly, you can type here 2 or 10 or something. But I propose to keep this like that, so you will always have the most freshest model.
Okay, thank you.
Well, okay. Yeah, I'll go then to the next notebook and show how we can generate images. But tomorrow we will work with this notebook for more time and generate not only images but also interpolations and videos and so on. Or maybe we can start now, but tomorrow we will do it again with your trained models. So for now, I will work with mine. So as usual, I have to mount the drive. And I have to run it in separate browser, because if I run in the same one, Collab will say like I have too many notebooks running at the same time. But I can use the same Google Drive. So like even if I run notebooks in different Google accounts, I still can connect the same Google Drive every time. So it will be stored on the same drive. Sorry, I have a Russian interface in this browser, but I will like explain everything that is different. But I hope you already know where is the files, where is everything. Yeah. So yeah, if I update it, I have all my files here, and yeah. So after I installed, after I mounted Google Drive, I will install the StyleGun again. I mean, it's already installed, so it will skip the installing StyleGun, and it will just load all the Python libraries needed to run the StyleGun. Yeah, and yeah, here we have a cell where we can convert the old StyleGun models. Like there is a different version of StyleGun 2, and the latest one is the one we use now. But a lot of people shared their models already. That was trained on the previous version, and if you want to use it here, you just need to upload such a model to your Google Drive, then provide path here, and then provide another path where you want to store the converted model. Yeah, and this is how you can update it to use with this version of StyleGun. And then when we have model, when we trained model, we can use it here. Like we can go to the lab SG2 to the results folder, yeah, and copy and paste the latest network snapshot. I will not do it right now because it's still training and it's still generate. It will generate some images that are not interesting. So I will use the model that I trained for Maria's project and that she showed yesterday. So it's just demonstration for demonstration purposes. And tomorrow we will do the same with your models. So yeah. Here we have a lot of parameters. Like the first one is where we will store the generated results. The second is the path for this network snapshot. In my case, it's this, but tomorrow we will copy it from these result folders. Then we have some StyleGun specific parameters. First of them is truncation parameter. It's like when StyleGun learns from the data, it forms so-called latent space or knowledge space, and it's like multi-dimensional space. It's like in case of StyleGun 2, it has 512 dimensions, and each point in this space is an image. And actually, when we generate the image, we just take this point, random or not very random, and save it to file. And truncation parameters somehow like says how big is the part from where we will take this point, how like yeah, how realistic this image will be, and usually people use values from 0.5 to 1 to generate realistic images. If you have less than 0.5, it will and you will generate lots of images. It will produce almost the same images. The variability will be not big, like they will look almost the same. And if you will have truncation more than 1, you will get some interesting artifacts. It's also sometimes it's also great to have it. Yeah, I will show you different examples how it looks like with different truncations. But for now, I will have this parameter, like this value. The next one is seed. It's numbers. It's like we can say that it's addresses of the images in this latent space, the knowledge space. Yeah, usually each image is described with 512 numbers, different numbers, but it's hard. Yeah, when you want to generate one, it's hard to type in all these numbers, and these seeds, it's like shortcut for this. So each number here corresponds to one image. Yeah. And you can, if you want to generate just one image, you provide just one number. But if you want to provide more than one, if you want to generate more than one image, you should provide the comma separated list of numbers. Yeah, like in this case, we will generate 3 images. This parameter, with seeds parameter, you can say to style GAN to generate some exact images, but you also can generate some random images. Then you should click on this checkbox, and then our script will ignore all these values and generate some random numbers. And you can adjust the amount of these random numbers. So like if I put 3, it will generate also 3 numbers. Yeah, I think we will generate these 3 seeds now. Maybe even 2 to make it faster. Then I will explain how truncation works, just demonstrate it. And after that, I will generate some random images and then non-square images. I will tell about this. Yeah, like, yeah, I will tell about non-square images a little bit later. Just show this example first. Oh, we already get it. Yeah, maybe by the time when I finish demonstrating this generation notebook, we will get some results, and we can generate some images with our newly trained model. Yeah, so when I run it, it loads the network I provided, yeah, and loading some libraries needed to generate, and then it will generate. And meanwhile, I will open this folder here. Minutes. Yeah, this one. For now it's empty, but yeah. Oh, now it should. Okay. Yeah. Now we have these two images. Seed. Yeah, we have the name of the seed number here. So later, if we want to generate new like interpolation video or something, we can check the numbers like, I like this image, I will use it in interpolation video. Yeah, so currently it generates this like wooden cell microscopic images, and yeah. Now I will try to generate the same, but with a truncation value like 2, for example. And we will get absolutely different result. Well, take some time, but like it takes some time when it's loading, but then generate pretty fast. So yeah. So I will have the same file names, but the images should look a bit different. No, it doesn't look much different. No, it looks different because I think I have to update the cache, the browser cache. Yeah, if I load it again. Yeah, you see when I set the bigger number of this truncation parameter, I get more chaotic image with some color blobs here or here. So it already lose this cell structure and start generating some random images. So the bigger the truncation number, the more chaotic results you will get. Sometimes it's great, like for some artistic experiments, it's great. But for our purpose, I think we need as the most realistic results. So I just told you about this parameter, but we will not use it. So I'll put it to 0.7, for example. Yeah. And now I will show how to generate random images. Yeah, so I will put this checkbox on, and for example, we will generate 10 images. So here it prints all the seed numbers, so you will know what exactly we're generating, and it will generate 10 images. So it will be saved in the same directory, but the file names will be different because we have different seed numbers. Yeah, good. So what we have here now? Yeah, we got more images. And as we have random numbers, the images look differently because they from different parts of this latent space. Yeah, and as we see, all images are square. Yeah, and there is a small hack how we can generate non-square images and bigger than 1024 pixels. To activate this hack, we should mark this checkbox and then define the resolution. Also, we have different scaling algorithms because our model it cannot generate the image bigger than 1000 pixels. It just generate different pixels and somehow merge them into the bigger image, and by choosing these changing these parameters, we will change how exactly it will fill the space of this image. I will generate just one seed here. Yeah. And we will see how this parameter affects the results. Yeah, so now it's generated, and if I go here and renew the directory, now we see that the image is bigger, like it's no longer square image, and the path parameter is just somehow replicate these images. We can see the same structure somewhere, like this part and this part look almost the same, and the only and this and this part is also the same, but in the middle we have something new. Yeah, I will rename it path, and then we will check another algorithm like path, like symmetry, I guess. From my practice, it depends on the data set. Like if we have data set that has patterns like this cell structure, or like if you generate cities, then like maps or something, then it's better to use path option. And if you use some, I don't know, not that structured images, the sim option goes better, but you always has to experiment and look at the results. Yeah, now you can see. Yeah, now we can see that the result is like the path just like make us, I don't know, we can compare it with stamp instrument from Photoshop. Yeah, it takes a part of the image and replicate it multiple times. symmetry sim option do a different stuff. I cannot explain exactly what it does, but it looks differently, and I guess sometimes you can see that it's the image becomes symmetrical, but in this case, yeah, I don't see it. Yeah, so this is the options how we can generate non-square images, and tomorrow we will use it. Yeah. Well, we already have 3 ticks, and I guess we can check the results. What results we have now? So I'll go to GAN folder to the results. Yeah, we can check the progress. Like here we still have faces, and if we go to the newer one, the faces start to degrading, and the freshest one, we still have this head structure, but we already don't have face there. Yeah. We still have this head, these shoulders, but we cannot say that this is the face. So I think if we wait for 1 or 2 more ticks, we will get the better results. So maybe you have questions now, or I can explain more about generation, show more generation options. Well, okay, if there is no question, yeah, I will show how to play more with truncation, because, yeah, we will not use it tomorrow, but I think it's nice thing to know. So for the, if in this option we can generate multiple images, here we generate just like we will generate multiple images, but for one seed. So it's one initial images image, but with different truncation values. So we will start from, for example, -1 and go to 2, and we can also define the step size. To make it faster, I will put it 0.1, but the smaller this value, the more smooth video you will get. Like it will generate multiple frames, like for each truncation value, and then it will make a video out of all these images. So I will start this. So I guess if we have 3, it will be something like 300 or 30 images. I don't know. I forgot all the arithmetics. Yeah, so we can see it generates images for each truncation value. Yeah, and we will have 30 frames. It will merge them into one video. So I guess it should be done. So if I go to yeah, back to the folder. Sorry, I have lots of folders for some reason. So here, yeah, when it generates frames, and we will see it later with interpolation, it will create the frames folder where the frames will be stored, and then it yeah, like here we can see the results. Something like this, yeah. And the video, the final video is like this. Yeah, it's pretty fast, but yes, you can see like we have here we have translation value -1. It's almost realistic, and then it became like somewhere here it's about 0, and we can see that multiple frames are looking almost the same, because has the same truncation parameter. And here we have like plus more than 1, and here it's something like 2, and it's very abstract, like it's really far from realistic image. Yeah, that's a way how you can experiment, and sometimes depending on data sets, sometimes it's nice to like you have to experiment and get the proper parameter, like when the images looks like more the more realistic. Yeah. So yeah, I don't know if we should go into interpolation. I thought we will do it tomorrow, and I think we will do it tomorrow because it's another big topic, and there is much more options to generate. Like yeah, we get another one more step here. So I will show how to generate images from your models that you trained by yourself. So yeah, I will copy the path to the latest network snapshot and generate it in this notebook. So here I'll provide the path. Here, yeah, I'll put it to this folder. And I will generate, for example, 20 minutes. Let's check what kind of results we have now. Interesting. There is definitely something wrong with this data set I made. What if I will generate just square images? Yeah. Because sometimes this non-square images hack doesn't work properly, and yeah, we should always test if it's okay or not. Yeah, so I generate the images, and I can check it here. Yeah, the faces almost disappeared, and we have this cell structure, but we still can see the, as we know that there was a human head before, we still can notice the structure. Yeah. So I guess after the next iteration, it will be it will disappear completely, and like in maybe 3 or 4 iteration, it will be almost like the reals. Yeah, but as we can see, it produces the result that we can work with later. I will try to generate non-square images, but with a smaller size, because it cannot generate much bigger images than it was trained to generate. So as I have 256 resolution, then I will try to generate, I don't know, 500 by 500. I don't know. Maybe it will work. No, it doesn't work. Well, okay. I guess I never met this error before when I used to work with the biggest resolution with 124. So I guess I will prepare a new data set and run the training process again. So I will stop it here. Yeah. Yeah, I will prepare a new data set. Yeah, like because this data preparation notebook doesn't use GPU, we can run it together with the training notebook. So yeah. Just need to be sure that everything will work for you with the bigger resolution. Okay. Providing the path to the input directory, then to the output directory. I will call it almost the same, but I will put the resolution here. It's always nice to put the resolution into directory name, so later you will understand what kind of images stored there. Yeah, and I will augment it. Sorry. Yeah, sometimes you can see this kind of errors, name error, name auth is not defined, or some other name is not defined. It means that you skip one of the previous cells and you didn't load the needed library. And I guess it happens here, not here, not here. Yeah, I forgot to run the first cell. Yeah, now it's done. So now I can run this cell. Yeah, this will take around 2 minutes to convert these images. Yeah, while it's converting, I guess we can generate some other stuff. I don't know what else to show here. Yeah, I guess we will just wait for the proper images and then we'll restart training. But this time we will not wait for the results of the training. We just check that it starts correctly with the provided, like with the default model. So almost there. Well, meanwhile, we get one more model. So while it's converting, I will just start making changes here. So now we will have and we will change the initial network snapshot. Yeah. So yeah, I guess we finished here, and I will stop training for now. Stop training, you can just click stop button, or you can right click on the cell and you will see here. Yeah, right now the cell is stopped, so you don't see it here, but there will be an option to interrupt the execution. So it's different ways. Also, if you like here we have output, yeah, the process, and if you want to get rid of it, we can just right click on it and click clear output. So now we don't have to scroll a lot. So yeah, I need to create new data set with the bigger images. Let's check what we will get. And while it's creating new data set, I guess we can check the latest changes and like check the latest network snapshot we trained before. So I'll go here, paste it. Just want to check some. Also, I just did it and remembered sometimes Google Colab has bugs, like if you delete the number from here, and then, oh, it seems like they fixed that. But sometimes when you delete the number and then try to put a new value, it doesn't update it in the code and can produce some kind of errors, like the value is not set. So you can double click and change it in the code. But looks like they fixed this, so it's great. Yeah, nice new things. I also learned something during this workshop. Yeah, so okay. Well, truncation 21 is too big. I will set it to 0.7. Yeah, and we can check. Oh, I saved it to the same folders. And, it will be hard to recognize what images are new and which images are new and which is old. So I'll change it to another folder and we run this now. So maybe we will get, yeah, we should get better results. Yeah. Also, we can check this folder. Maybe we will see it like with our own eyes, the difference. I don't see much difference. Yeah, we can look at the time when it was created. Like this is the older model. We can see the head here, and it's a newer one, and the head is like I can see these heads already anywhere because I have generated lots of images and I can notice the slight presence of the head, but anyway, it's less visible, like almost invisible now. So we got some results we can work with, but of course for tomorrow we need to train it in bigger resolution. Yeah, and right now I will start doing this just to check that everything is fine. So I run this. I also can check that the resolution is proper now. Go here. Yeah, it's bigger. It should be proper size. Yeah, we don't have any errors for now. I guess there was some mess with standard models provided by NVIDIA for the lower resolution, and as everyone wants to generate the best resolution possible, so there is no problem with bigger model. Yeah, we're almost there. Yeah, the first tick started. So yeah, as the image size is bigger, the training time is also increased. Like yeah, it's 4 times slower, almost 4 times slower than before, because the image is 4 times bigger, yeah, or 8 times bigger. Yeah. Anyway, it's working now, so I'm sure that you will not have any problems with this. But if you will have, please write to the WhatsApp chat or to me directly. Yeah. So I think that's all for today. So I will stop sharing. But if you have any questions, please ask me now. Maybe some of you followed me and met some interesting, maybe some problems, maybe got some interesting results. Maybe someone want to share their results. No? Well, then we will
I just have a general question.
Yeah.
Like if we are to use our own data sets,
Yeah.
do you have any general guidelines as to what kind of images we need, or what works, what doesn't work?
Yeah, I guess for this workshop, it's better to have images that have this kind of structure, like cell walls or something like this. So what we will do next, we will generate interpolations between these steps. Yeah. So this cell structure will be like extruded into the like that dimension. Yeah. So if it has these walls, we will have these walls in 3D model. So it's better to have like proper contours of the objects on your images, but you can use any of them. Like we did it with satellite imagery on the previous workshop. It also works. Yeah. But yeah. Yeah, I think with like images with some structures, like proper edges, good contrast, yeah, will work.
Okay. Thanks.
So then tomorrow we will meet at 4, if I'm not mistaken. Yeah, I have this different time zones, so always have to convert it in my head. Yeah, and I hope by that time you will have your own models trained on your data sets or on data sets that we provided, and we will generate these interpolations. So like what is interpolation is just intermediate images between two other images. Like today we generate these single images. Now we will have like smooth images between them. Yeah, and after we will generate these interpolations, we will convert it into point clouds, and later on Tuesday, you will work with those point clouds in Rhino together with Maria. Yeah, that's the plan. Thank you for joining, and yeah, I will stop the YouTube.